This is the last sum, and this deals with trigonometry mostly. So number 1. So y equals to tan x plus 2 cos x. We have to find the derivative. So this is the derivative of trigonometric. So let me write it out. So trig derivatives. So suppose you have to find the derivative of tan theta, any angle, ax plus b. So the derivative of tan theta, let me call this theta as a pronoun. It is sec squared, meaning secant squared, sec squared theta. And remember the chain rule for every derivative, d by dx of the algebraic portion. So this is the derivative of tan. Tan theta derivative is sec squared theta. The next one is d by dx of cos theta. Let me call the theta ax plus b. Whatever the theta is, doesn't really matter. The derivative of cos theta is minus sine theta. Remember that the derivative of cos theta is minus sine theta. And the chain rule, of course, d by dx of ax plus b. Now there is a question all the time, what formula will be given in the formula booklet. You know, there will be a formula booklet given to you in the exam hall. So let's take a look at the formula booklet. So this is the formula booklet. This will be given in every exam, and the formula booklet is C1 to C4, FP1 to FP3, M1 to M5, S1 to S4, but really you don't have that much of a formula. Let's go to the menu. This is the main page, table of contents. So C1, C2, C3, C4. C3 we have logarithms and exponentials, trigonometric identities and differentiation, and for C4 we have only integration. Okay, this is C3. Now we have this formula, not much of, we cannot use this that much. We have this sum of angles of sine and cos and tan. We have these rules that does not come in, it's not that much common for having this, and we have the derivatives. Now this is what we are interested in. For the derivatives, let me expand it a little bit. So we have the derivative of tan theta. So tan theta is sec squared theta. So we do have the derivative of tan theta that we need here, but you do not have the derivative of anything else, sine or cos. You have the higher one, sec theta is sec tan, cot theta is minus cosec squared theta, cosec theta is this, and you also have the formula of quotient formula, u by v. So that's what you have in the C3. So remember that these are the formula that will be given. Derivative of sine and cos will not be given, so it's highly recommended that you memorize these things, but these things you might not need to memorize. Okay, so let's get back to the sum. So we have to find the derivative. So therefore y, derivative of y is dy by dx. So derivative of tan theta is sec squared theta. Chain rule is d by dx of this is 1, so I'm not writing it out. So this will be minus, this will be 2 plus 2, and derivative of cos theta is minus sine theta. Chain rule is 1, I'm not writing it out. So it would be sec squared x minus 2 sine x. Now we have to find the value of the derivative at the point x equals to pi by 4. First, it's always a good idea to write down the answer in the simplest form, sine, cos and tan. So sec, the identity is 1 by cos. So this will be 1 by cos squared x minus 2 sine x. So at x equals to pi by 4, we can just write dy by dx equals to 1 by cos pi by 4 whole squared. Remember, cos squared theta is the same as cos theta whole squared minus 2 sine pi by 4. Now pi by 4 means 45 degree. So if we take out our calculator, and you should have this memorized, that cos 45 degree is what? 1 by root 2. So cos 45 degree is this 0.707, but if you write it in decimal it won't work. So you have to remember it is 1 by root 2. So this will be 1 by root 2 whole squared minus 2. This is 1 by square root of 2. So this would be 1 by half, 1 by square root of 2 whole square is half, and this will be 2 by square root of 2. We continue here. So 1 by half is 2 minus 2 by square root of 2. Now one recommendation is, this is from C1 surds, it's always a good idea not to have any square root downstairs. It's something that mathematicians, they don't prefer it at all. So you can just rationalize this surd by multiplying with root square root 2 upstairs and downstairs. This is from the C1 rationalization concept. So this would be 2 into square root of 2 is 2 square root of 2, and square root of 2 into square root of 2 is 2. So this 2 and this 2 cancels off. It will be 2 minus square root of 2. So this is what they prefer. So please remember, no square roots downstairs. So the next one is another derivative of another trigonometric function, but this one is implicit. Remember what implicit is. Implicit, this derivative, this is usually found in C4, although it's in the C3 syllabus. So it's like when you have to differentiate something with y, suppose a y to the power n, you just differentiate in the same way you would differentiate x. Just with it you have to write dy by dx. This is implicit. Explicit means y equals to explicitly of x. Implicit means x and y mixed together such that you have to do this sum using this rule. So you have x equals to tan half y, meaning y by 2. So therefore when you differentiate x, we have to differentiate this. When you differentiate x, you get a y, you get a 1. When you differentiate tan theta, this is theta, remember it is sec squared theta, and there is the chain rule of d by dx of the angle y by 2. So this is what you get. Now if you simplify, 1 equals to sec squared theta. Now d by dx of half y is going to be half, but with it we have to write dy by dx. Remember, like this, we have to write dy by dx. So let's simplify. 1 equals to, now we can write half into sec squared y is reciprocal of cos squared theta, so y by 2. Sec squared theta, theta is y by 2, is 1 by cos squared theta. This is dy by dx. So now what we can do, we can send this to the other side. So we can write it like this, 2 into 1 into this, we can write 2 into cos squared theta equals to dy by dx. So this is what we can write. Now maybe it was not a good idea because we now have to prove something. So maybe it was not a good idea to convert the sec into cos, because we don't have to find dy by dx, but we have to prove something here. So let me get back a little bit. Let me do one thing. Let me send this half here downstairs, so it will be 1 by half, and let me keep the sec squared here for the time being, dy by dx. So it would be 1 by half is 2 equals to sec squared theta is y by 2 dy by dx. Now if I send this sec squared downstairs, it would be 2 divided by sec squared theta equals to dy by dx. I'm not using that identity of reciprocal because I need to prove something here. So dy by dx equals to 2 divided by sec squared. Now remember the identity. There is an identity which is tan squared x plus 1 is identical to sec squared x. Now we are going to need that identity here. So instead of writing sec squared theta, I can write 1 plus tan squared theta, or tan squared theta by 1. The theta is y by 2. So this is how it works. But here in the answer, we have to write down the answer in terms of x. That means, remember, x equals to tan theta by 2, theta meaning y by 2, tan y by 2. So here we can, instead of this, we can write 1 plus tan squared theta is x squared. Remember, x equals to tan y by 2. So instead of tan y by 2 whole squared, we can write x squared. That's the expression proved. Now the final one is a trigonometric sum. That's a very common sum in trigonometry. But before that, one thing that needs to be done is we need to differentiate this before we talk about this sum. So this question number 3, this question number 3 is we have to find the derivative. So dy by dx of this one, so it is going to be the product rule of derivative. So d by dx of uv is going to be u d by dx of v plus v d by dx of u. That's what it's going to be. So this one is going to be the u, so e to the power minus x d by dx of sine 2x plus sine 2x, this is the v, d by dx of e to the power minus x. So let's break this down. E to the power minus x into sine, the derivative of sine is cos, so cos theta, and the chain rule is going to be derivative of the angle 2x is going to be 2 plus sine 2x, and you know the derivative of e to the power anything is the same thing, so it will be e to the power minus x, and the chain rule is derivative of minus x is minus 1. So let's simplify this. So write the constant first. There is a good way of ordering this. Write the constant first, then write e to the power minus x, then write cos 2x. Here write down the constant first. The constant is minus 1, then write e to the power minus x. So there is no need to write 1, you can just write e to the power minus x and sine 2x. Okay, so we can just take the e to the power minus x common, so it becomes 2 cos 2x minus sine 2x. So that's what dy by dx is. Now the question is, we have to show that dy by dx in the form of, if you pay attention, we have a capital letter R, a number, and we have this thing. E to the power minus x is the same. So what they are actually telling us, we have to show 2 cos 2x minus sine 2x is r cos 2x plus alpha. This is what we have to show, and we have to find to 3 significant figure the value of r and alpha. Let me repeat. The first question was find the derivative of y, find dy by dx. So we found the derivative of this dy by dx, and we found in the form e to the power minus x and this algebraic thing 2 cos 2x minus sine 2x. This is what we found, but instead they are telling us to express it as r e to the power minus x cos 2x plus alpha as the angle. So since e to the power minus x and e to the power minus x, this is the same, so we actually have to express this portion as r cos 2x plus alpha. So that's the main thing that we have to do here. So this is a very common sum. It's another type of trigonometric sum that we can expect. There are actually 3 or 4 very common sums that comes alternately. So there is a rule of doing this sum, so you need to memorize how this sum is done, and you have to really pay attention how to do this particular sum. So let me go over here, let me write it out over here. So let me write it out over here. When you have a sine x, let me call it theta, plus b cos theta, and you have to express it as r cos theta plus something else alpha, and it could be something else also. It could be r sine theta plus alpha, it could be r sine theta minus alpha, it could be r cos theta minus alpha, it could be anything. The main thing is a sine theta plus b cos theta has to be expressed in this format. So you have to find the value of r and alpha. So now for the value of r, very simple, the formula is r squared equals to the coefficient of one, a squared, plus the coefficient of the other thing, cos theta, is b squared. That's it, that's the formula. So let's go ahead and do this. So the first thing, so r squared equals to, the coefficient of cos theta is 2, so 2 squared, plus the coefficient of sin theta is minus 1 squared, so this is going to be 4 plus 1 5. Therefore r equals to plus minus square root of 5. Remember, they have mentioned you have to find the value to 3 significant figure. That's what you have to find, and you have to find the values of r. This is very, very important. So if we bring out our calculator, what is square root of 5? 2.23607. 2.23. Let me double check. 2.23607. So this is the value of r, plus minus. Remember, if you have a square, if it goes to the other side, it becomes plus minus. So the answer should be r equals to 2.23 significant figure, 1 2 3, 2.24, or r equals to minus 2.24. So we found the value of r. Now we have to find the value of alpha. Remember, alpha has to be in radian, also in 3 significant figure, 0 to pi by 2, meaning 0 to 90 if it was in degrees, but this has to be in radian. So let's move on to see how to find the value of alpha. Now for finding the value of alpha, what we need to remember is this: sine alpha by cos alpha, this is tan alpha. That's it. That's all we need to know. We need to know the value of sine alpha, and we need to know the value of tan alpha. That's it. So then we can find the value of alpha by tan inverse of that thing. That's it, nothing else to it. So what we can do here now, we can just break this down and see what this is really made up of. For 2 cos 2x minus sine 2x equals to r, if we break cos 2x plus alpha as cos a plus b, this is going to be cos minus, the r will be multiplied, sine. That's the formula of cos a plus b. So let's compare now. So we need tan alpha. So tan alpha is sine alpha by cos alpha. So therefore sine alpha. So now here, what do you have with sine alpha here? So sine alpha here equals to, so here you have sine 2x. This is very, very important. What you need with sine alpha on this side, so you're with sine 2x. If you have sine 2x on this side, you have minus r sine alpha. So let me write out minus r sine alpha. So this is, you're comparing sine 2x. If you compare sine 2x on this side, it is going to be minus 1. Let me repeat. Where do you have sine alpha? If you take sine 2x with sine 2x on the left side, you have minus r sine alpha. So I wrote minus r sine alpha. Here you have sine 2x, with it you have minus 1, so I wrote minus 1 divided by cos alpha. With cos 2x you have r and cos alpha, so let me write r and cos alpha. On the other side with cos 2x you just have 2, so I wrote 2 here. So what we can do here now is we can just cancel this r and we can cancel this r. We can write minus sine alpha by cos alpha is minus tan alpha equals to, this is minus half, and we can cancel this minus and this minus, and we'll have tan alpha equals to half. Now remember, we have to find the value of alpha. This is not one of those trigonometric solving. Remember, very, very important. This is just find the value of alpha. We don't have to do quadrant and basing angle or anything. We just have to find the value of alpha. Very simple. Therefore alpha equals to arc tan of half, or tan inverse half. And remember, the answer has to be in 3 significant figure in radian. So change the mode. Remember to change the mode all the time. So mode 2, 3, 4. Radian means number 2. Now we have converted this into radian mode. So tan inverse of half means 0.5 equals to 0.46365. So this would be 0.46365, which means alpha to 3 significant figure is 0.464. So we have found the answer to both. So now we have to restate the final answer. R equals to plus minus 2.24, alpha equals to 0.464. It's always important to restate the answer.